Hello everyone, welcome to this daily coding where we are going to go through number of ways to stay in the same place after some steps. So what is happening is that you receive as input a number of steps you need to apply, and you receive a kind of frame in which you should stay while applying those steps. And at the end of the operation, we need to count how many possibility do you have to end up at your starting position. So this is the scenario this is what you're supposed to implement here. And then for us to have a better visualization of what you are supposed to implement, let me grab this. So let's say you have, these are the number of slots. So we have the slot 1, which is I just give index 0. So we have an array of length 2. That means we have two possible slots, which is the first and the second slot, and then we have 3 steps. Now initially you are at position 0, right? If initially you are position 0, now let us compute and see exactly what is the mechanism of steps. So you are going to say I'm at position 0 at step 1. Since I'm at position 0, I can either stay at position 0, this is the stay 1, or I can move one step forward. If I move one step forward, I'll be here, or I can move one step backward. I'm already at position 0, so I cannot move one step backward. So if we are to end at position 1, we will have one possibility to end at position 0 and one possibility to end at position 1. Now let us move to the second step. Now in the second step you can either, for each of the previous step, like, okay, if I was at position 0, what would be my possible move for the next step? So if you are position 0, you have the possibility to stay at position 0 or to move to position 1, right? Now if you were at position 1, what are your moves? You can move one step backward, or you can stay, but you can't move one step forward because there is no possible for you to move. So if you are to end here, the solution is that you have two possible way of ending at position 0 and two possible way of ending at position 1. Now let us hit the last one to see exactly how it behaves. So we are going to say, for each of those positions, what are the possible move? I can either remain here. If I want to remain here, I mean like those two, we are going to have this and this. The color is not nice. Let us take something brighter. So we can take this and this, and then we can either remain here or we can move one step forward. We are going to have 1, 1, and then the same for those guys, the same for this. If we are here, what are the possible moves? Those two, they can either remain at position 2 where they are. Unfortunately, they cannot go forward because there is no possible slot after this, but they can come back to here, which is here. So basically, by doing so, you can see that at the end of the operation, how many possibility do I have to stay at position 0? There are 4. So this is the answer. That is why for this you can see that the answer is 4. So the goal of the example was just to show you exactly how the process is supposed to behave, right? Now how are we going to approach it? Now we know some example, we know exactly what we need to implement, how we're going to approach it. Before diving into understanding how to approach it, yes, Agro Architect, if you're new here, I really encourage you to subscribe to don't miss what you're doing here in terms of LeetCode daily acquiring solution. So if you try to level up your competence in data structure, algorithm, and problem solving, don't hesitate to subscribe. You are at the right place. So now how are we going to solve it? How are we going to approach it? So before approaching it, I'm going to present the thing in a different way. So let's say we are going with another example of tree. By tree I means we have a number of slots of 3. That means we can have 3 slots. That means we have 1, 2, 3 slots, and we are going to apply 3 steps. 1, 2, 3 steps. So what we are going to say is that at the first step, we can either remain at position 0 or move at position 1. So this is the state of the first step, which is actually the basic state. We can either move at position 1 or remain at position 0. Now for the second step, we are going to say, okay, each of the previous step will actually be used, right? So if we were at position 0, we can either move to 0 or 1. Exactly. If we are at position 1, we can either go back to position 0, remain at position 1, or move to position 2. So this is actually the state of position 2. Now this is actually the brute force approach. Now you can see that we have repetition. We have 0 that's appearing 2 times. We have 1 which is appearing 2 times. And basically each of those 0 are actually going to return the same result. So if you are able to compute the possibility of a given element 0 like this, you don't need to compute the other one. You can just reuse it. So for us to better make use of this repetition, we are going to transform our representation into a map where we are going to have each element with a number of occurrence. Now that we are going to have element with a number of occurrence, what we are going to do is that we are just going to compute the number of occurrence. We are going to compute the number of possibility of each of the element, and we are going to say, okay, this element actually appeared this occurrence, and just reuse it. What will it look like? We are going to say, okay, 0, what are the possibility of 0? Since 0 can lead you to 0 or 1, and each of those elements actually has an occurrence of 2, we definitely end up with 0 2 times and 1 2 times. That is why we have 0 2 and 1 2. Now we are going to move to the next one. We are going to move to the next one, which is actually 1. And for 1, we are going to say 1 can actually lead us to 0 1 or 2, right? And since we have 1 appearing actually 2 times here, that means 0 can appear twice. Or we are already having 0 appearing twice here. So we are going to say 0 now will appear 2 times 2, which is actually 4. We are going to say 1 will appear 2 plus, it's plus 2 plus 2, which is actually 4. And then this 2 will appear 2. Why do we have this 2 will appear twice? So 2 is actually 2, not 1. And then now, yeah, it's appearing twice, it's 2 now. And then the last one, the 2 has an occurrence of 1, so we are going to say 2 can lead us to 1 or 2, because when you are at 2 we cannot move forward because we are going to exceed. We can only stay, which is 2, or we can move backward, which is 1. And then those elements actually appear only 1 time, so we are going to say 1 will appear 1 time. 1 was already 4 here, so 1 will become 5. And then 2 is appearing 1 time. 2 was already 1 year, 2 was already 2 years, so 2 will be 3, right? And then at the end of this, you can just return the occurrence corresponding to position 0. So that is our idea, that's our goal here. Let us validate this and see exactly if it's work, right? So for us to implement this, we are going to have each of the step will actually be like a position of a vector, and each of the element of the vector will actually be a map that will represent the status of that position. So we are going to have vector of 0, which is actually going to have this position, vector of 1, which is going to have this map. So we are going to have a vector of map, and for each of the element we are going to reuse the previous answer to compute the answer at the current stage. So the implementation will look like this. So I have a vector of map, and then this vector of map is actually the representation of all this. And then now what I'm saying that I'm trying to initialize my first occurrence, so I'm creating a map which is actually trying to create the occurrence of the first element in my vector. And I'll say mp of 0 will actually be 1. Why am I saying that? Because I know that no matter what is happening, initially I can be at position 0, right? So at position 0 I have at least one possibility. Now if I have an array which has a size greater than 1, that means adding to the fact that I can stay at position 0, I can also move one step forward. Because if the array has a size which is exactly 1, that means I cannot move forward. I already know that I can't go backward. That is why I have just two opportunities during the initialization, either stay or move, and I can move only if the size is greater than 1. That is why I have this extra check before performing this. And after this, I will then initialize my vector, the first occurrence, with this MP, this map, and then I will have the for loop that will have all my logic. For each of the occurrence of the for loop, I will start by clearing my map to have something empty that I can use to populate data. And for now, each of the element, I will take my previous element, because like I said, you are using the previous one to compute the current. So I will take the previous one, which is what I'm doing here. And after this, I will look through all of the occurrence of the previous one. That means I will look through all of them. So when I will be here, for instance, I will take this and I will look through 0, 1, 2, exactly what we did here. And for each of the element, I'll just compute. If by adding one element, I'm still in the frame, then yeah, cool. That means I can, the number of occurrence of that element, this is each dot second, I can take it and add to the previous result which we were having. And I need to apply the modulo here because the answer can be really big. So you need to apply this modulo. So I apply this and I update the occurrence at that position. And then if by reducing one element I'm still in the frame, then cool, I can actually make the same thing. I'm 100% sure that by remaining at the position where I am, I'm in the frame, right? So that's why I don't need extra check for this. That's why for this I just make this, and then at the end I will say the vector at that position will take the map that has been created during this for loop. And at the end I just need to return the vector of the last element at position 0, because the problem here is to find exactly how many occurrences we have to remain in the same position, and our initial position is position 0, so I just return position 0. So this was my approach of solving this. Maybe you want me to run maybe for this the tree that I was talking about. If you were talking about the tree, let us run. You'll see. So the tree is actually returning 4, which is what we were having here. And to just validate that our approach is actually implementing what we think we are implementing, let us check for the element at position 1 and element at position 2 and see exactly how it behaves. At position 1, you will have to check position 1. Eventually, it will fail, but we are checking just to make sure that our implementation is correct. So at position 1, we have a result of 5. So you can see that this is 5. At position 2, what we lost have. At position 2, we have a result of 3. We have an output of 3, which is actually here. So you understand that the logic we are implementing here is actually something which is correct, and it has been correctly implemented here. So this was my approach to solving this. I hope you enjoy it. Feel free to leave me any comment that will help to kind of make this better. So don't hesitate to like, share, subscribe. See you tomorrow with new challenge. Ciao.